Assalamualaikum and good day. I am Mulyani representing my group ComX from College Matrikulasi Johor will present our innovation project titled MISD, a microscope slide detector. After a practical session, a lecturer must physically check all the apparatus, whether the students have returned them or not. The lecturer must check the apparatus one by one at different storage places. If an apparatus is missing or not returned, the lecturer must tell the students to find it, and this will cause a delay in time for the lecturer to end the class and for the students to move to their next class. Because of this, the students have to rush to their next class and might get themselves hurt on the way. So our group have invented an innovation that will allow the lecturers to spend less time to do a physical check of the return apparatus, and also to allow the students to have more time to pack their belongings and move to their next class calmly and safely. Our innovation is called Microscope Slide Detector, MISD. Currently, application of Internet of Things (IoT) technology have helps to improve the quality of higher education. Radio frequency identification (RFID) is one of the key technologies to implement IoT applications. MISD uses the basis of RFID technology. MISD consists of components which are tags and readers. The microscope slide detector are used to detect the used and returned microscope slides after an experiment involving observing slides under a microscope. MISD systems are a type of labeling or tagging system that incorporates RFID technology. An MISD system typically consists of three main components, which are RFID chip, an antenna, and a label material. So the basic components to build a MISD circuit are RFID card reader detector for Arduino, solderless breadboard, Arduino jumper wire, and Arduino LCD display, blue backlight screen. In producing this microscope slide detector MISD, there are some basic requirements that need to be met as shown in figure. Among them are object detection, object analysis, warnings and notification, integration with the system, compatibility, ease of use of the product, and the cost effectiveness of the product innovation. MISD have two modes of function, which are either direct USB cable or by using batteries, and the average cost of buying the components to build MISD system are around 20 to 30 ringgit Malaysia only. So how do we apply MISD in a practical session? So after a laboratory session is finished, it is required for a lecturer to check and make sure that all the used apparatus, including microscope slides, are returned at their respective storage places. However, when there are a limited amount of time available for the lecturer to physically monitor all the apparatus, there are still students who do not return the microscope slides. This is proved by the complaints received by the lecturers as shown in the figure. To overcome the problem, the researcher has made a checklist for the return of microscope slides in the specimen box that has been prepared in MISD system. If the student does not return the slide to its original place, this system will emit an output through a system signaling the lecturer that the microscope slide have not been returned. A manual usage of MISD during a laboratory class are illustrated in the figure above. So first, students have to scan tag to MISD reader. MISD reader read the tag name and time in and record it in Google Sheet. Experiment is conducted, and after the experiment ends, students scan the tag to MISD reader again. The MISD reader read tag name and time out and record it in Google Sheet. And lastly, the lecturer will enter the MISD system and check the record only by using mobile phones or laptops. A total of 25 Johor Matriculation College biology lecturers have used the MISD innovation. All the lecturers stated that MISD are a good alternative method of helping to reduce the time required to check the microscope slides. Hence, both the lecturer and the students are able to finish the laboratory lesson faster so they can move to the next class calmly and start their next lesson on time. From the graph, it showed that 96% of the lecturers who use MISD system are able to finish their class 15 minutes earlier compared to the ones that did not use MISD system circuit. Lecturers are able to enter the system and check directly what apparatus that have not been returned instead of doing a physical checking. The questionnaires were distributed to students after the practical session. Data analysis shows that 98% of the students agree that MISD have helped them to increase the time required for them to pack their belongings after an experiment is conducted and allows them to move to the next class and arrive there faster. Many benefits can be obtained when MISD are implemented in biology experiment class, such as reduce the need for physical inventory counts, can eliminate time-consuming procedures, each laboratory class can end earlier without hassle, next laboratory class can start on time, and students can go calmly to the next class without any injuries. MISD have received a certification from MyIPO because of its many benefits to the lecturers and the students. So in conclusion, we can say that with MISD, a 2-hour practical session for biology subjects can be more effective and efficient. MISD is originally innovated by our group members and have yet been applied to other matriculation colleges. It is planned that in future, MISD could be applied to other subjects for their stocking tracking. Secondly, it is planned to create MISD circuit in a strip form so it is easier to paste on surfaces of apparatus and be used in tracking of assets in College Matrikulasi Johor. So that is all from our group from College Matrikulasi Johor for MISD, Microscope Slide Detector. Thank you.